At first, crossing space sounds like a question of speed. Build a faster ship, find a better engine, travel long enough. And eventually, maybe humanity could leave the Milky Way and reach another galaxy. But the deeper we look at the universe, the worse this idea becomes. Because the distance between galaxies is not just far, it is a scale so enormous that even light begins to feel slow. A spacecraft could travel faster than anything humanity has ever built, and still spend millions of years crossing the darkness between the Milky Way and Andromeda. And that is only our nearest major galactic neighbor. Beyond Andromeda, the distances grow into tens of millions, hundreds of millions, and billions of light years. Galaxies that look close together in space images may actually be separated by oceans of darkness so wide that entire civilizations could rise and disappear before a message ever arrives. Tonight, on What If Beyond, we are going to explore why intergalactic distance is far worse than most people imagine. We will travel beyond the Milky Way, across the silent space between galaxies, into the cosmic web, the great voids, and the expanding universe itself. And the more we understand these distances, the more terrifying one truth becomes. The universe is not built for easy travel. Before we continue, tell me in the comments, what time is it where you are right now? And from which city are you watching? And if you enjoy calm documentaries about space, galaxies, and the mysteries of the universe, consider subscribing to What If Beyond. Now, dim the lights, get comfortable, and let us begin a journey into the impossible distance between galaxies. At first, the idea sounds almost simple. If another galaxy is out there, somewhere beyond the Milky Way, then maybe the only thing standing between us, and it is speed. Build a better engine, use more energy, travel for a long enough time. And one day, a spacecraft might cross the darkness between galaxies. But the universe is not arranged like a map on a table. It does not care about the way distance feels inside the human mind. And the moment we begin to measure the real spaces between galaxies, the dream of crossing them starts to change. It becomes heavier, colder, more silent, and far worse than it first appears. To understand why, we need to begin close to home. Not with another galaxy, not even with another star, but with the small world beneath us. Earth already feels enormous. A person can spend a lifetime traveling across it and still never see every mountain, ocean, desert, forest, and city. An airplane crossing the planet can take many hours. A ship crossing an ocean may take days or weeks. In human life, Earth is large enough to feel like an entire universe. But from space, Earth is only a sphere of light and cloud. From the moon, it becomes a glowing blue world, hanging in blackness. From Mars, it becomes a bright point. From the outer solar system, Earth nearly disappears. And from the distance of another star, it would be almost impossible to notice at all. This is the first warning. Scale changes meaning. What feels vast from one position becomes tiny from another. The solar system itself is far larger than Earth. The moon is already far enough away that light needs more than 1 second to cross the distance. Mars, depending on where it is in its orbit, may be tens or hundreds of millions of kilometers away. Jupiter is farther still. Saturn, Uranus, Neptune, the Kuiper Belt, and the distant icy bodies beyond Neptune all stretch the solar system into a realm where ordinary distance begins to fail. A spacecraft leaving Earth must travel for months just to reach Mars. years to reach Jupiter, almost a decade to reach Saturn, longer still to reach the edge of the planetary region. Voyager 1, one of humanity's most distant spacecraft, has been traveling for decades. It is now far beyond the major planets. It has entered interstellar space, and yet, compared with the distance to the nearest stars, it has barely begun to move. This is where the scale becomes strange, because the solar system is already enormous, but the distance to the nearest star system is far worse. Proxima Centauri, part of the Alpha Centauri system, is more than 4 light-years away. 1 light-year is the distance light travels in 1 year. Light moves at about 300,000 kilometers every second. In 1 second, it can circle Earth more than 7 times. In 1 year, it crosses nearly 10 trillion kilometers. And the nearest star is more than 4 of those light years away. If a spacecraft like Voyager 1 were somehow aimed in the right direction, it would take tens of thousands of years to get near another star. Tens of thousands of years just to reach the closest neighboring star system. That alone is enough to challenge every idea we have about space travel. Human civilization has not existed in its modern form for anything close to that length of time. Languages rise and vanish in far shorter periods. Nations appear and disappear. Religions spread and transform. Technologies are invented, forgotten, rebuilt, and replaced. A journey to the nearest stars would already outlast everything we recognize as history. And still, this is only interstellar travel. Travel between stars. Inside one galaxy, the Milky Way contains hundreds of billions of stars. It is not just a cluster of nearby suns. It is a massive rotating structure of stars, gas, dust, dark matter, black holes, star-forming regions, ancient clusters, and spiral arms. Our Sun is only one ordinary star, located far from the galactic center, orbiting quietly inside one part of the galactic disk. From Earth, the Milky Way appears as a pale band across the night sky. Because we are inside it, we do not see its full spiral shape from the outside. We see its stars, dust, and light from within the disk. But if we could leave the galaxy and look back, the Milky Way would appear as a vast spiral island of stars. A glowing structure perhaps 100,000 light-years across. That number is almost impossible to feel. 100,000 light-years means that even light, moving at the fastest speed allowed by physics, would need 100,000 years to cross the galaxy from one side to the other. A beam of light leaving one edge of the Milky Way would travel through space while entire human civilizations rise and fall, and still it would not have reached the other side. If the Milky Way were the whole universe, it would already be too large for us to cross with any technology we have now. But the Milky Way is not the whole universe. It is one galaxy, one island, one structure among countless others. And when we look beyond it, we find the real problem. The nearest major galaxy to us is Andromeda. It is often described as our galactic neighbor. That word sounds comforting. Neighbor, something nearby, something across the street, something close enough to visit if the journey is difficult but possible. But in the universe, the word neighbor becomes almost cruel. Andromeda is roughly 2.5 million light-years away. Not 2.5 million kilometers, not 2.5 million astronomical units, 2.5 million light-years. Light itself needs more than 2 million years to cross the distance between the Milky Way and Andromeda. When you look at Andromeda, you are not seeing it as it is right now. You are seeing ancient light. The photons reaching your eyes began their journey before modern humans existed, before cities, before writing, before farming, before every country, every empire, every language we speak today, before the oldest monuments on Earth, before almost everything we think of as human history. That light crossed intergalactic darkness while Earth changed beneath it. Ice ages came and went. Ancestors of humans walked across ancient landscapes. Species evolved. Others vanished. The climate shifted. Continents slowly moved. And only now does that light arrive. Andromeda is our neighbor, and yet the light from it is older than humanity's story. This is the first moment when the distance between galaxies becomes frightening, because Andromeda is not a distant galaxy in the extreme sense. It is close. It belongs to the same small galactic family as the Milky Way. It is part of the local group. It is one of the closest large galaxies to us. And still, it is so far away that even a message traveling at light speed would need millions of years to reach it. Imagine sending a simple signal. One word. Hello. If that signal were sent from Earth toward Andromeda tonight, it would travel outward at the speed of light. It would leave the solar system. It would cross interstellar space. It would pass beyond the stars of the Milky Way. It would continue through the galactic halo. Then it would enter the immense darkness between galaxies. The signal would keep moving. Year after year, century after century, millennium after millennium. Human civilization on Earth could transform completely, while the message was still nowhere near its destination. After 100 years, the signal would be only 100 light years away, a tiny distance on the scale of the galaxy. After 10,000 years, it would still be inside the Milky Way. After 100,000 years, it might only have crossed a distance comparable to the width of our galaxy, and Andromeda would still be millions of light years away. Only after more than 2 million years would the signal arrive. If someone there received it and answered immediately, their reply would need another 2.5 million years to return. One exchange, one hello, and one answer. 5 million years. That is not communication in any human sense. It is not a conversation. It is not even a delayed message like sending a letter across an ocean. It is closer to archaeology. A message becomes a fossil of intelligence, traveling through time until someone in a completely different age finds it. By the time a reply came back, the civilization that asked the question might no longer exist. The planet might have changed. The species might have evolved. The language might be gone. Even the meaning of the original message might be forgotten. This is what intergalactic distance does. It does not only separate places, it separates moments. It breaks the shared present. And this is only between the Milky Way and Andromeda. Beyond Andromeda, the distances become even more severe. Galaxies exist millions, tens of millions, hundreds of millions, and billions of light years away. Some galaxies we see in deep space images are so distant that their light began traveling before the Earth existed in its present form. Some are seen when the universe itself was young. The sky is full of galaxies, but most of them are not nearby islands waiting to be reached. They are ancient lights from unreachable depths. This is why space images can mislead us. A telescope image may show many galaxies in one frame. A bright spiral here, a smaller galaxy nearby, a faint red galaxy behind it, a field filled with hundreds or thousands of glowing shapes. To the eye, it seems crowded. It feels like the galaxies are close together. But the image is flat. It compresses depth. It hides distance. Two galaxies that appear beside each other in a photograph may not be close at all. One may be millions of light years away. Another may be billions. One may belong to a nearby cluster. Another may be far in the background. From a much earlier age of the universe, the image places them together because their light arrives from the same direction in the sky. But in reality, they may be separated by distances that no spacecraft could ever cross. The universe does this constantly. It places objects side by side in our view, while keeping them separated by unimaginable depth. The night sky is not a surface. It is a tunnel through time. Every direction opens into layers: nearby stars, farther stars, gas clouds, star clusters, distant galaxies, ancient galaxies, light from the early universe. When we look up, we are not looking at one moment. We are looking through history. And galaxies are the most dramatic reminder of that. They look like objects, but they are also timestamps. Andromeda is a view from more than 2 million years ago. A galaxy 100 million light years away is a view from 100 million years ago. A galaxy 1 billion light years away is a view from 1 billion years ago. The farther the galaxy, the more ancient the image. This creates a strange truth. If we ever tried to travel to a distant galaxy, we would not be traveling to the galaxy we see. We would be traveling toward what it has become after millions or billions of years of change. The photograph shows its past. The journey would aim at its future. During the crossing, stars inside that galaxy would move. Some would die. Others would form. Gas clouds would collapse. Supernovae would explode. Black holes would feed. Galaxies might merge. Entire structures could change. The destination would not wait frozen in the shape we observe. Even if travel were possible, the map would be made of old light. This is one of the most difficult ideas in astronomy. Observation is not the same as access. Seeing something does not mean we can reach it. Knowing where it was does not mean we know exactly what it is now. The universe gives us information, but always with delay. Nearby, that delay is small. We see the moon as it was just over a second ago. We see the sun as it was about 8 minutes ago. We see Jupiter as it was tens of minutes ago, depending on where it is. These delays are real, but they still feel manageable. For stars, the delays become years. For galaxies, they become millions or billions of years. And when distance becomes that large, the delay changes the meaning of reality. You are no longer looking at a place. You are looking at a surviving message from a vanished moment. This is why the distance between galaxies is worse than a number. A number like 2.5 million light years can be spoken quickly. It fits easily into a sentence, but the reality behind it is almost impossible to hold. 2.5 million years is longer than every city, every nation, every known civilization. It is longer than written history many hundreds of times over. It is longer than the existence of modern humans as a species. And that is just the distance to one nearby galaxy. Try to imagine traveling that distance with a spacecraft. Suppose humanity builds an engine far more powerful than anything we have today. Suppose it can reach 1% of the speed of light. That would be an extraordinary achievement. At 1% of light speed, a spacecraft would travel around 3,000 kilometers every second. That is far beyond current human spacecraft speeds. It would cross the distance from Earth to the Moon in minutes. It would cross the solar system in a time that feels astonishing compared with today. But to Andromeda, it would still take about 250 million years. 250 million years. That is not a journey. It is a geological era. A spacecraft launched at 1% light speed would take longer to reach Andromeda than the time since the earliest dinosaurs. Earth would not be the same planet when it arrived. Continents would move, mountains would rise and erode, oceans would shift, species would evolve and vanish. The sun would age, the Milky Way itself would continue changing, and the spacecraft would spend almost all of that time in darkness. Now imagine 10% of light speed. This is far beyond our current capability. At 10% of light speed, the ship would still need about 25 million years to reach Andromeda. 25 million years is shorter than 250 million, but it is still beyond human civilization. It is longer than the time since many major groups of animals appeared in their current forms, longer than countless evolutionary stories, longer than any culture could expect to preserve one mission without becoming something completely different. Even at a speed that seems almost magical by today's standards, the nearest major galaxy remains millions of years away. This is why intergalactic travel is not merely a harder version of interstellar travel. It belongs to another scale of impossibility. A trip to a nearby star could be imagined with future technology, perhaps using robotic probes, light sails, fusion engines, or other advanced systems. It would still be incredibly difficult, but the target is at least within a few light years. A trip to another galaxy requires not only speed, but survival across time so vast that the ship becomes a civilization, a machine ecosystem, or something entirely new. A normal spacecraft is not enough. A crewed ship would need to support life across countless generations. It would need a stable environment, energy, food production, water recycling, protection from radiation, protection from dust impacts at high speed, medical systems, education, governance, culture, memory, purpose. It would need to survive long after Earth's original mission planners were gone, long after the languages of launch had changed, long after the home planet became an ancient myth to those aboard. A generation ship crossing intergalactic space would eventually become its own world. The people inside might not think of themselves as travelers. They might think of the ship as home. They might not feel the journey, because outside the windows, almost nothing would change. At first, leaving the Milky Way would be visually dramatic. The galaxy might grow behind them as a great spiral of light. Its disk would stretch across the darkness. Its center would glow. The sun would become one star among billions, then disappear into the collective light. The ship would move beyond the familiar stellar neighborhoods. It would pass through the halo. Globular clusters might appear like ancient swarms of stars. Streams of stars from destroyed dwarf galaxies might trace faint arcs around the Milky Way. Then, slowly, the density of stars would decrease. The galaxy would fall behind. Ahead, Andromeda would remain distant. For a long time, the ship would be between galaxies, not inside one island, not yet inside the next. This region, intergalactic space, is not perfectly empty. It contains extremely thin gas, particles, magnetic fields, dark matter, radiation, perhaps wandering stars, rogue planets, and small objects thrown out of galaxies. But compared with the richness of a galaxy, it is almost nothing. No dense star fields, no nearby suns, no planets waiting every few months, no bright nebulae filling the sky. Most of the journey would take place in darkness, and that darkness would last not for days or years, but for time spans beyond any human emotional reference. This is where the psychological scale becomes as terrifying as the physical scale. Humans are creatures of change. We understand movement, by watching surroundings shift. A road moves beneath us, a coastline fades behind us, a mountain grows larger ahead. Even on long voyages across Earth's oceans, waves, weather, and stars give a sense of passage. But between galaxies, a traveler may spend a lifetime seeing almost no change. The Milky Way behind the ship would shrink too slowly for one generation to notice easily. Andromeda ahead would brighten too slowly to feel like a destination. The ship would move at incredible speed, yet the universe would look almost still. This is the cruelty of cosmic scale. Speed becomes meaningless when distance is too large. A spacecraft could travel faster than anything humanity has ever built, and the view might remain nearly unchanged for thousands of years. Progress would need to be believed through instruments, measured through data, taught through history. The destination would be not something seen growing each day, but something promised by ancestors. A mission like that could begin as science, then become tradition, then become myth. The original reason for leaving might transform over time. The people born aboard the ship would never have seen Earth. Their children would never have seen the Milky Way from inside. After enough generations, the idea of a planet under an open sky might feel strange. The ship's corridors, habitats, artificial gravity, farms, schools, and observation decks would become the only reality. Andromeda might be taught as the destination, but would it still matter? Would a civilization remain committed to a goal chosen millions of years before? Would they still want to arrive? Would they fear arrival? Would they decide that the ship itself is enough? Intergalactic distance does not only challenge engines, it challenges identity. Because the traveler must last so long that the traveler changes. Even a robotic mission faces a similar problem. A probe sent toward Andromeda would need to operate across millions of years. Our current spacecraft are extraordinary, but they are fragile on those scales. Electronics degrade, power sources weaken, cosmic rays damage components, memory can corrupt, microscopic dust can strike at high speeds, thermal stress accumulates, materials age, software errors can become fatal. A probe crossing intergalactic space would need to repair itself, perhaps rebuild itself, maybe replicate parts, maybe mine material from rare objects, maybe carry artificial intelligence capable of adapting for millions of years without instruction. At that point, it would no longer be a simple probe. It would be a self-sustaining explorer, a machine descendant of humanity. And if it finally reached Andromeda and sent back data, the signal would take millions of years to return. The civilization that launched it might not exist. The language of the data might be unknown. The receiving world might have changed beyond recognition. A successful mission could become unreadable. This is the strange tragedy of traveling between galaxies. Even success may arrive too late. A photograph from another galaxy would be one of the greatest achievements imaginable. But if it returned millions of years after the mission was forgotten, who would receive it? Who would understand what it meant? Who would remember the hands that built the probe? Across intergalactic distances, achievement and memory can separate. A civilization might send its greatest creation into the abyss, and the answer might return to silence. This is why galaxies feel so unreachable, even when they are visible. The universe allows us to see them, but seeing is not the same as touching. Light from Andromeda reaches us freely. It crosses the darkness without fuel, without machinery, without survival systems, without purpose. A photon simply travels. It does not experience time in the way a spacecraft does. It does not need to preserve memory. It does not need to repair damage. It does not need a crew. It can cross 2.5 million light-years and enter a telescope on Earth. Because of that, astronomy is possible. But matter is different. Matter must be moved, protected, maintained, guided. A telescope receives the universe. A spacecraft must fight its way into it. This difference is one of the deepest truths of space exploration. Humanity is rich in vision and poor in reach. We can see galaxies billions of light years away. We can photograph them, measure their redshifts, estimate their masses, study their shapes, observe their star formation, detect their central black holes, watch them merge. But physically reaching even the closest major galaxy may remain beyond us forever. Knowledge travels farther than bodies. Perhaps this is how the universe is meant to be known, not by crossing every distance, but by interpreting the light that crosses it for us. Still, the mind resists this. When we see a galaxy, we imagine going there. When we see a bright spiral, we imagine worlds inside it. When we see Andromeda, we imagine a destination. But the universe answers with time. 2.5 million years for light, tens of millions of years at impossible ship speeds, hundreds of millions at more realistic future speeds. And beyond Andromeda, the numbers become worse. The Virgo cluster lies tens of millions of light years away. The Coma cluster lies hundreds of millions. Distant galaxies seen in deep field images may lie billions of light years away. Some of those galaxies are so far away that cosmic expansion changes what reach even means. Because the universe is not static. The space between distant galaxy groups is expanding. On small scales, gravity holds structures together. The solar system does not expand. The Milky Way does not expand. The local group is gravitationally bound. But between distant, unbound regions, space itself stretches. This expansion means that many galaxies are moving away from us, not because they are flying through space like rockets, but because the space between us and them is increasing. The farther away a galaxy is, the more expanding space lies between us. At great enough distances, galaxies can recede in a way that makes future contact impossible. This does not mean they locally break the speed of light. It means the distance itself grows. A beam of light sent today towards some distant galaxies may never arrive because the space between continues stretching too quickly. This is one of the most frightening ideas in cosmology. Some galaxies we can see today are already beyond future reach. Their ancient light reaches us because it left when the universe was smaller. But if we send a signal now, it may never get there. They are visible, but unreachable. They are part of our observable past, but not our accessible future. The universe shows us places that are already slipping away. This makes the distance between galaxies worse than a journey across emptiness. It becomes a race against expansion. And for many destinations, the race has already been lost. No engine can reach everything. No civilization can contact every galaxy. No future technology, if it remains bound by the speed of light and the structure of space-time, can make the entire visible universe accessible. The observable universe is not the same as the reachable universe. We can see farther than we can ever travel. This changes the emotional meaning of the night sky. It is not a map of possible destinations. It is an archive of light. Some of the galaxies in that archive may still be connected to us in the future. Others may not. Some are neighbors in the broad cosmic sense. Others are ghosts of regions that have already passed beyond any possible communication. The sky is filled with ancient messages from places we may never influence. And when we realize this, the universe becomes both more beautiful and more lonely. Because the galaxies are real, their light is real, their history is real. But many of them are not part of our future. They are memories arriving from across a growing darkness. This is why the distance between galaxies is not only a measurement, it is a boundary around communication, around travel, around shared time, around what any civilization can ever know directly. Even a civilization far more advanced than ours would face these limits. It might spread across its own galaxy. It might send probes to nearby galaxies in its local group. It might build machines that survive for millions of years. But the entire universe would remain too large. Expansion would divide the cosmos into regions, some accessible, some visible only in the past, some forever beyond the horizon. There may be no civilization that can own the universe, no empire that can cross every galaxy, no final traveler who visits all islands. The universe is not built like a kingdom waiting to be conquered. It is more like an ocean whose far shores are moving away faster than any ship can follow. And yet, we are not completely helpless. Because we can look, we can measure, we can think. A small species on one planet inside one galaxy can understand that Andromeda is millions of light years away. It can calculate how long light takes to arrive. It can map galaxy clusters. It can detect cosmic expansion. It can build telescopes that see ancient galaxies near the beginning of cosmic history. This is astonishing. Our bodies cannot cross the distance, but our minds can model it. Our instruments can receive its light. Our mathematics can describe its behavior. In that sense, astronomy is the first and perhaps greatest form of intergalactic travel. Not travel through space, travel through evidence, travel through photons, travel through time. Every image of a distant galaxy is proof that something crossed the abyss. Not us, not our machines, but light. And when that light arrives, it changes what we know. It tells us that the Milky Way is not alone. It tells us that galaxies gather in groups and clusters. It tells us that the universe has structure. It tells us that there are voids where almost nothing shines. It tells us that space is expanding. It tells us that the cosmos has a history. The light from another galaxy is a messenger that survived a journey beyond imagination. And we, for a brief moment in cosmic time, are able to receive it. But even this gift is temporary. In the far future, as expansion continues, distant galaxies will become harder to see. Their light will be stretched to longer and longer wavelengths. They will grow dimmer. Many will disappear beyond practical detection. The Milky Way and Andromeda will merge into a larger galaxy. The local group will remain as a gravitational island. But the wider cosmic web will fade from view. Future observers may look into the sky and see far fewer clues of the vast universe we see today. They may not easily know that billions of other galaxies once filled the observable sky. They may think their local galaxy is nearly alone. The universe may hide its own scale with time. This means we live in a rare era. Not because we are central. We are not. Not because our galaxy is special. It is one among many. But because the universe is old enough for life to ask questions, and young enough that distant galaxies are still visible. We are able to see the cosmic web before it fades beyond the horizon. We can observe galaxies whose light began traveling billions of years ago. We can study the expansion that will one day isolate future regions. We can know that the darkness is filled with structures far beyond our reach. This knowledge may be one of the greatest privileges of our moment in cosmic history. We cannot cross the distance between galaxies, but we can recognize it. and recognizing it changes everything. It makes the Milky Way feel both enormous and small. Enormous because it contains hundreds of billions of stars. Small because it is only one island. It makes Andromeda feel both nearby and impossible. Nearby because it is our galactic neighbor. Impossible because its light is older than humanity. It makes deep space images feel both crowded and lonely. Crowded because galaxies fill the frame. Lonely because every one of them is separated by depths the image cannot show. It makes the universe feel both connected and divided. Connected by gravity, light, and cosmic history. Divided by distance, expansion, and time. This is the beginning of understanding intergalactic space, not as empty background, not as a simple gap between bright objects, but as the dominant reality of the cosmos. The galaxies attract the eye. Their spiral arms, glowing centers, dust lanes, and star-forming regions are beautiful. But the space between them is where the true scale lives. The darkness is not just absence, it is distance, it is delay. It is the reason messages become ancient. It is the reason journeys become myths. It is the reason visible galaxies can still remain unreachable. And the deeper we move into this idea, the worse it becomes. Because the Milky Way and Andromeda are only the first step. They are close compared with the greater universe. Beyond them lie galaxy clusters, superclusters, cosmic filaments, and voids so large that even galaxies become rare. There are regions of space where the nearest major galaxy may be millions of light years away in every direction. There are structures so vast that light itself needs hundreds of millions of years to cross them. There are distances so great that expansion changes whether contact is possible at all. And as we continue outward, one truth becomes impossible to avoid. The universe is not simply big, it is separated. Separated by space, separated by time, separated by the limits of communication, separated by horizons we cannot cross. A galaxy may shine in our sky tonight, but its presence is hidden. A spacecraft may aim toward it, but the journey may outlast every memory of why it began. A signal may leave Earth, but the answer may return to a world that no longer exists. This is why the distance between galaxies is worse than we think, because it is not just far. It is far in every way that matters, far from our bodies, far from our machines, far from our conversations, far from our present, far from our future reach. And yet, across that terrible distance, light still arrives, quietly, patiently, from Andromeda, from Virgo, from distant clusters, from galaxies so old that their light began traveling when the universe was young. The darkness is vast, but it is not silent. It carries messages, and those messages tell us that beyond the Milky Way, beyond our local stars, beyond everything that feels familiar, there is a universe of galaxies shining across oceans of time. The journey has only begun, and already the distance is almost too much to understand. The deeper we move beyond the Milky Way, the more the idea of travel begins to fall apart. Not because space is empty, not because there is nothing to explore, but because the universe is built on scales that do not match the lifetime of anything we know. A human life is measured in decades. A civilization may survive for centuries, perhaps thousands of years, if it is fortunate. A species may last for hundreds of thousands or millions of years, but the distance between galaxies asks for something far longer. It asks for patience on the scale of evolution. It asks for machines that can survive longer than mountains. It asks for messages that remain meaningful after the world that created them has changed beyond recognition. And that is only the beginning. Because even if we imagine a spacecraft powerful enough to leave the Milky Way, another problem appears immediately. The destination is not standing still. Andromeda is not a fixed object waiting at the end of a straight road. The Milky Way is moving. Andromeda is moving. The local group is moving. The Sun is orbiting the center of the Milky Way. The Milky Way itself is drifting through space under the influence of surrounding galaxies, clusters, and invisible dark matter. Everything is moving at once. So a journey to another galaxy is not like firing an arrow at a target painted on a wall. It is more like launching a tiny grain of dust across an ocean toward an island that is also moving, while the ocean itself is changing shape. A spacecraft leaving the Milky Way would need to aim not at where Andromeda appears in the sky now, but at where Andromeda will be millions of years in the future. And because we see Andromeda as it was more than 2 million years ago, even the position we observe is already old information. Astronomers can calculate its motion. They can estimate its path. They can predict the future merger of the Milky Way and Andromeda. But for a real spacecraft, small errors would matter. Over millions of years, a tiny mistake in direction could grow into a massive miss. A small deviation at launch might become thousands of light years of separation later. The longer the journey, the more unforgiving navigation becomes. On Earth, a ship can correct course. An aircraft can adjust its path. A spacecraft traveling to Mars can receive new instructions. But in intergalactic space, communication delays become enormous. A command from Earth may take thousands, then millions of years to reach the spacecraft. The ship cannot depend on home. It must navigate by itself. It must know where it is in a universe with almost no nearby landmarks. It must measure the motion of galaxies. It must track pulsars, background radiation, gravitational influences, and the changing positions of distant objects. It must update its own map while traveling through a region where almost everything is ancient light. This is another reason intergalactic travel becomes strange. The map is not only spatial, it is historical. The stars and galaxies used for navigation are seen through delays. Some are where they appear to be only in a past sense. Some have moved, some may have changed, some may no longer exist in the same form. A spacecraft crossing the darkness would navigate through ghosts of light. The farther away a reference point is, the older its visible position becomes. To travel accurately, the ship would need to predict not only where objects are, but where they have become. This means intergalactic navigation is not just astronomy. It is prophecy based on physics. And even if the spacecraft could navigate perfectly, the journey would still be dangerous in a way that is easy to underestimate. Many people imagine empty space as safe. No atmosphere, no weather, no mountains, no oceans, no traffic, just darkness. But emptiness becomes dangerous when speed becomes extreme. A spacecraft traveling at a significant fraction of the speed of light would collide with even tiny particles with devastating energy. A grain of dust too small to notice on Earth could strike like an explosive impact. A molecule of gas becomes part of a constant high-speed stream. Radiation increases. Cosmic rays become a threat. The front of the ship would need shielding stronger than anything ever placed on a spacecraft. It might need layers of ice, magnetic fields, plasma shields, or sacrificial material designed to absorb impacts for millions of years. And the faster the ship travels, the worse these impacts become. Speed helps with distance, but it also turns the darkness itself into a hazard. This is the cruel balance of space travel. Move slowly, and the journey takes impossibly long. Move quickly, and even dust becomes dangerous. Between galaxies, where the trip already lasts millions of years, every design choice becomes extreme. A small spacecraft may be easier to accelerate, but harder to protect and repair. A large spacecraft may carry more shielding and resources, but requires far more energy to move. A crewed vessel requires living systems. A robotic probe requires survival systems. A generation ship requires civilization inside metal. There is no simple version of the problem. Every solution creates another impossible demand. Energy is perhaps the most obvious one. To accelerate anything massive to a significant fraction of the speed of light requires an enormous amount of energy. Not just fuel in the ordinary sense. Energy on a planetary or stellar scale. A small probe might be accelerated by powerful lasers, fusion engines, antimatter concepts, or methods we have not yet developed. But a large vessel carrying people, habitats, farms, shielding, spare parts, and power systems would be far harder. The more massive the ship, the more energy it needs. And if it needs to slow down when it arrives, it must carry or collect the ability to decelerate as well. Reaching another galaxy is not only about launching fast, it is about arriving. A spacecraft that flies through Andromeda at extreme speed without slowing down would collect data only briefly. If the goal is settlement, study, or long-term exploration, the ship must reduce its velocity. That means either carrying fuel for both acceleration and deceleration using external methods, or relying on advanced techniques like magnetic sails, interacting with interstellar or intergalactic material. But intergalactic space is extremely thin. There may not be enough material to slow down efficiently until the ship approaches a galaxy, and by then it is traveling dangerously fast through increasingly dense regions. Arriving may be almost as hard as leaving. A mission must survive the journey, reach the target, slow down, avoid hazards, find useful systems, and still have enough functioning technology to operate after millions of years. And after all that, the galaxy it reaches may not be welcoming. A galaxy is not a single destination. It is a massive system. Andromeda contains stars, gas, dust, radiation, stellar remnants, black holes, globular clusters, and dark matter. It has regions where stars are born, regions where old stars dominate, regions shaped by past mergers, regions full of dust that blocks light. A spacecraft entering Andromeda would not suddenly arrive at a planet. It would arrive in another enormous galaxy, still needing to travel between stars. After crossing millions of light years, the ship would face the same problem on a smaller scale. Where exactly should it go? Which star? Which planet? Which region? If the goal is to find a habitable world, the spacecraft must search again. Another galaxy is not a guaranteed home. It is another cosmic ocean. This reveals one of the most important misunderstandings about intergalactic travel. People imagine the hard part is reaching the next galaxy. But reaching the edge of another galaxy is not the end. It is the beginning of another search. Inside Andromeda, stars are still separated by light years. Planets are still tiny. Useful worlds are still difficult to detect and reach. Even if Andromeda contains billions of planets, a traveler arriving blindly would need to find the right one. A galaxy is not a city with lights and roads. It is a vast gravitational structure where the useful places are hidden among unimaginable emptiness. So the ship must not only be an intergalactic traveler, it must also become an explorer inside the destination galaxy. It must carry telescopes, probes, mapping systems, and perhaps the ability to build new machines from local materials. It must be able to survive after arrival without support from home. It must become independent in the deepest possible sense. At that point, the mission stops being a journey. It becomes a seed. A civilization or machine launched into darkness to begin again somewhere else. And this brings us to a more unsettling question. Why would a civilization try? Why cross millions of light years when the Milky Way itself contains hundreds of billions of stars? If humanity ever develops the ability to travel between stars, our own galaxy offers an almost endless frontier. There are nearby red dwarfs that may live for trillions of years. There are star-forming regions, ancient stars, white dwarfs, rogue planets, brown dwarfs, planetary systems waiting to be studied. The Milky Way is so large that exploring even a small part of it could occupy civilizations for millions of years. Before another galaxy becomes necessary, our own galaxy would remain almost completely unknown. This is why intergalactic travel may not be a natural goal for most civilizations. The reward is not obvious. Another galaxy contains more stars. Yes, but if your own galaxy already contains more stars than you could visit in any reasonable time, the next galaxy may not offer enough to justify the cost. Only a civilization thinking across enormous timescales might consider it, perhaps because it wants to spread life as widely as possible. Perhaps because it wants to preserve intelligence against future disasters. Perhaps because it wants to explore for exploration's sake. Perhaps because it has reached such technological maturity that even galaxies become steps. Or perhaps because the far future makes it necessary. The Milky Way will not remain unchanged forever. Stars die, new stars form. The Sun will not support Earth forever. The galaxy will merge with Andromeda. Star formation will eventually decline. Over extremely long times, the universe itself changes. A civilization that survives long enough may begin to think not in centuries, but in billions or trillions of years. For such a civilization, intergalactic travel might not be about curiosity. It might be about survival across cosmic time. But even then, the options are limited. The local group is gravitationally bound, which means the Milky Way, Andromeda, Triangulum, and smaller galaxies remain part of one local structure. Over billions of years, they will interact and merge into a larger galaxy. For inhabitants of that future system, nearby galactic material may become one combined home, but galaxies outside the local group will continue moving away as the universe expands. The longer a civilization waits, the farther many destinations become. Cosmic expansion creates a kind of deadline. If a civilization wants to reach distant galaxy groups, it must act before they become unreachable. But the energy and technology required are so extreme that acting early may be impossible. By the time a civilization becomes capable, many regions may already be beyond reach. This is one of the strangest traps in cosmology. The universe is most reachable when civilizations are least prepared. And when civilizations become advanced enough to try, the universe may have become more isolated. There is a mismatch between biological time, technological time, and cosmic time. Life needs billions of years to evolve. Intelligence may appear late around a star. Technology may take time to develop. But cosmic expansion does not wait for anyone. The largest map of reachable destinations slowly shrinks. This means the far universe is not just difficult, it is slipping away. Galaxies are not only distant objects, they are disappearing opportunities. Not disappearing from existence, but disappearing from possible contact. The light we receive from them may continue for a time, but our ability to influence them fades. A future signal may never arrive. A future spacecraft may never catch up. The visible universe becomes a museum of places no one can visit. This is where the phrase "it gets worse" becomes true in a deeper way. First, galaxies are far. Then we learn they are so far that light takes millions of years. Then we learn that spacecraft would take far longer. Then we learn that communication becomes meaningless. Then we learn the destinations move. Then we learn the universe expands. Then we learn that some galaxies we can see are already beyond our future reach. At every step, the problem becomes more severe. The universe is not simply large. It is structured to separate. Gravity brings some things together. Expansion carries others apart. Time delays all knowledge. Distance erases detail. And the farther we look, the more we see not accessible places, but ancient evidence. This does not mean the universe is empty of connection. Galaxies are connected by gravity. Galaxy clusters are bound systems. The cosmic web forms great filaments where matter gathers. Light travels between galaxies. Gas flows through large-scale structures. Dark matter shapes motion across enormous regions. But these connections are slow. They do not create easy roads. They do not create conversations. They create patterns across time. The universe is connected like a fossil is connected to the living thing that left it. Through evidence, through structure, through history, not through immediate contact. To see this more clearly, imagine zooming out from the Milky Way. At first, the galaxy fills the view. A grand spiral, bright center, curving arms, dust lanes, star clusters. The solar system is too small to see. Earth is completely invisible. Then the Milky Way shrinks, and Andromeda appears nearby. Triangulum appears as another member of the local group. Dwarf galaxies surround the larger ones like faint companions. This is our local family. Already, the distances are huge. But keep zooming out. The local group becomes a small structure. Other groups appear. Then the Virgo cluster. Then larger arrangements of galaxies. The view becomes a network. Galaxies gather along filaments. Clusters form at intersections. Between the filaments, enormous dark voids open. At this scale, galaxies are no longer isolated objects. They are bright particles tracing an invisible architecture, the cosmic web. This web is not made of stars alone. It is shaped mostly by dark matter, the unseen mass that guides the formation of galaxies and clusters. Ordinary matter falls into the gravitational wells created by dark matter. Gas cools. Stars form. Galaxies grow. Over billions of years, the web becomes more distinct. Dense regions become richer. Voids become emptier. From far away, the universe looks almost biological, like a network of glowing nerves. But inside that beauty lies the same terrible scale. The filaments can stretch for hundreds of millions of light years. The voids can be larger than entire superclusters. A galaxy cluster that seems enormous becomes only one knot in the web. The spaces between the knots are so large that even galaxies become rare landmarks. If a spacecraft thought the distance to Andromeda was bad, a cosmic void would be worse. A void is a region where the density of galaxies is far lower than average. It is not absolutely empty. There may be faint galaxies, gas, dark matter, and radiation. But compared with the filaments and clusters, it is a vast cosmic desert. Some voids are so large that crossing them at the speed of light would take hundreds of millions of years. A traveler inside one would see distant galaxies around the edges, but few nearby destinations. The void would feel like space emptied of its islands. This changes the emotional meaning of the universe. We often focus on the bright things: stars, nebulae, galaxies, clusters, but the volume of the universe is dominated by the dark spaces between structures. The bright objects are rare compared with the spaces that separate them. A galaxy is enormous from within, but tiny compared with the voids between cosmic filaments. The universe is not a crowded city. It is an archipelago of light in an ocean of darkness. And the ocean is expanding. Inside a void, the problem of navigation becomes even stranger. A ship may have no nearby galaxy to use as a reference, no local stars, no nearby gas clouds, only faint background radiation and distant structures. The ship's instruments might still detect the cosmic microwave background, distant quasars, galaxies, and gravitational effects, but the sense of place would become abstract. Location would be defined by coordinates in a map too large to feel real. A civilization aboard such a ship would not experience the universe the way we do. They would not live under a sky full of familiar constellations. They would live inside a manufactured world, surrounded by faint ancient light. Their connection to the cosmos would be almost entirely mathematical. The outside would not provide daily meaning. It would provide data. This matters because long journeys are not only technical, they are cultural. A civilization that lives for millions of years inside a ship must create meaning from its environment. It must maintain stability without natural seasons, natural landscapes, or a home planet's cycles. It must decide how to preserve history, how to educate children, how to prevent collapse, how to handle conflict, how to keep the ship functioning, how to adapt without losing the mission. The distance between galaxies forces society itself to become part of the spacecraft. A broken engine is dangerous, but a broken culture may be worse. If the ship's society loses trust, purpose, or cooperation, the mission ends long before any mechanical system fails. Intergalactic travel would require not only physics, but sociology across geological time. And that may be the hardest problem of all. We know how difficult it is for human societies to remain stable for even a few centuries. Institutions change, conflicts arise, knowledge can be lost, priorities shift. Now imagine asking a society to preserve one technical mission for millions of years. Not because arrival is tomorrow, not because the destination is visible as a growing world, but because ancient ancestors chose a galaxy that no living person has ever known. At that point, the mission is almost impossible to separate from belief. The ship must believe in a future it will not see. And if it does arrive, the arrival could be frightening. A civilization born in transit may not want a planet. It may not want open skies. It may not trust natural environments. It may see the destination as dangerous, chaotic, and alien. For them, the ship is not a vehicle. It is home. A galaxy is not salvation. It is outside. This is one of the strangest consequences of intergalactic distance. A journey long enough can transform the travelers so deeply that the destination loses its original meaning. The people who arrive are not the people who left. They may not even consider themselves the same species, culture, or civilization. The distance does not only move them through space, it changes them through time. Robotic explorers might avoid cultural drift, but they face another kind of identity problem. If a machine must repair itself, adapt, rewrite software, rebuild hardware, and survive for millions of years, how much of the original probe remains? A self-modifying explorer might evolve technologically during the journey. It might improve its own design. It might abandon parts of its original mission. It might decide that survival requires new priorities. If artificial intelligence becomes independent enough to endure intergalactic time, it may no longer behave like a tool. It may become a descendant, a new kind of entity traveling between galaxies. Perhaps any successful intergalactic mission must become something beyond its creators. Either a ship civilization that changes biologically and culturally, or a machine intelligence that changes technologically. Nothing static survives the distance. This may be one of the deepest lessons of galaxies. To cross them, you cannot remain the same. The universe demands transformation. And yet, even transformation may not be enough for the farthest galaxies. Because beyond the local group, expansion slowly dominates. A civilization could adapt, build, travel, and still find that most of the universe is outside its reach. This sets a limit on ambition. There may be no path to every galaxy, no way to gather all knowledge directly, no way to unite the cosmos under one living network. The universe may be permanently fragmented into regions that can never exchange present information. Each civilization, if it exists, may be trapped within its own cosmic neighborhood, able to see distant lights, unable to join them. This possibility makes our view of galaxies feel almost sacred. A distant galaxy is not simply a possible destination. It may be a final message, a piece of the universe we can observe but never touch. Its light tells us it exists. Its redshift tells us how space has stretched. Its shape tells us something about its history. Its color tells us about its stars. Its brightness tells us about its mass and distance. But its present remains hidden. Its future may be disconnected from ours. There may be life inside it that will never know we existed. And we may never know if it lived. The distance between galaxies turns much of the universe into a one-way revelation. We receive light from the past. We cannot send ourselves into that past. We may not even be able to send a signal into its future. That is why looking at galaxies can feel both inspiring and heartbreaking. They are beautiful because they shine. They are heartbreaking because they are so far that beauty may be the only contact we ever have. Still, the fact that their light reaches us matters. A photon crossing millions of light years does something no ship can yet do. It leaves one galaxy and arrives in another. It travels through the dark medium between islands. It survives expansion, time, and emptiness. It enters an eye, a telescope, a detector. It becomes knowledge. In that moment, the separation is not erased, but it is understood. And perhaps understanding is the first form of crossing. The universe may not allow us to visit every galaxy, but it allows the galaxies to become part of our awareness. That awareness changes the human story. For most of history, people saw the night sky as a nearby dome of lights. Then the stars became distant suns. Then the Milky Way became a galaxy. Then other galaxies became worlds of stars beyond our own. Then the universe became an expanding cosmic web. Every step pushed us farther from the center. Every discovery made space larger. Every measurement made human life smaller in scale, but larger in understanding. The distance between galaxies is part of that same humbling process. It tells us that reality is not built around our reach. It tells us that the universe contains more than any civilization may ever physically explore. It tells us that seeing and reaching are different powers, and it tells us that knowledge may be our most realistic way of touching the unreachable. But the journey outward is not finished, because beyond the idea of distance lies an even darker question. If galaxies are so far apart, and if many are moving beyond reach, what happens to the future of the universe? Will the sky grow emptier? Will galaxies disappear from view? Will future civilizations be trapped inside isolated islands of stars, unable to see the wider cosmos that we can see today? And if the universe continues expanding, does intergalactic distance eventually become not just difficult, but absolute? To answer that, we have to go farther, beyond the Milky Way, beyond Andromeda, beyond the local group, beyond clusters and filaments, into the spaces where cosmic expansion quietly decides what can still be connected and what is already gone forever. There is a point in this journey where distance stops feeling like distance. It becomes something stranger, a limit, a boundary, a slow separation written into the structure of the universe itself. When we first imagine galaxies, we picture them as objects scattered through space. The Milky Way here, Andromeda there, other galaxies beyond them. If the distance is large, then maybe the solution is simple in principle. Move faster, survive longer, and keep going. But the universe is not a silent stage filled with objects waiting in place. It is expanding. And because it is expanding, the space between distant galaxies is not only wide, it is changing while light, matter, and signals try to cross it. This changes everything. A spacecraft can move through space. A beam of light can move through space. But on the largest scales, space itself also evolves. The distance between distant galaxy groups increases as the universe expands. The path is not fixed. The road stretches during the journey. This does not matter on small scales. Earth is not expanding away from the moon because gravity binds the Earth-Moon system. The solar system is not being stretched apart by cosmic expansion because the sun's gravity holds it together. The Milky Way is not expanding internally in the ordinary sense because gravity holds the galaxy together. Even the local group containing the Milky Way, Andromeda, Triangulum, and many smaller galaxies remains bound by gravity. But beyond these gravitational islands, across the great spaces between galaxy groups and clusters, expansion becomes the dominant story. The farther a distant galaxy is, the more expanding space lies between us and it. And the more expanding space lies between us, the more difficult it becomes for anything sent today to ever arrive. This is where the universe becomes more disturbing than a simple map, because there are galaxies we can see that we can never reach. Their light reaches us because it began traveling long ago, when the universe was younger and the distances were different. But if we send a signal towards some of those same galaxies today, the signal may never arrive. It can travel at the speed of light, obey every law of physics, and still fail to reach the destination, because the space between us and the destination grows too much over time. The galaxy remains visible as an ancient image, but its future is disconnected from ours. This is one of the most powerful differences between the observable universe and the reachable universe. The observable universe is the region from which light has had time to reach us. It is the sphere of cosmic history we can receive. It contains galaxies whose light left them billions of years ago and has finally arrived at Earth. But the reachable universe is smaller. It contains only the regions that something leaving from here now could still influence in the future. A message, a beam of light, a spacecraft, a civilization. And because expansion continues, the reachable region is not the same as the visible one. Seeing is not reaching. A telescope can receive ancient light from a distant galaxy, but a future signal from us may never reach that galaxy in return. The universe allows us to observe places that are no longer part of our possible future contact. This makes deep space images feel different. A field filled with galaxies is not a catalogue of destinations. It is a record of arrivals. Light arrived. Information arrived. History arrived. But the galaxies themselves may be moving into a future where no reply from us can ever touch them. They become cosmic memories, not reachable worlds. This idea is difficult because our everyday experience teaches the opposite. If we can see a building, we can walk toward it. If we can see a mountain, we can imagine climbing it. If we can see a ship on the horizon, we can imagine sailing toward it. But the universe breaks that intuition. At cosmic scales, visibility does not guarantee access. A galaxy can shine in our telescopes, while its current reality is already beyond our future influence. It can be part of our sky and still outside our destiny. That is far worse than ordinary distance. Ordinary distance says it is far. Cosmic expansion says it may be far in a way that no journey can solve. Imagine standing on a shoreline and seeing lights across an ocean. At first, you think the problem is building a boat. Then you realize the ocean is widening faster than your boat can cross. The lights are real. They are visible. Their glow reaches you. But the shore itself is slipping away. That is what some of the universe is like. Not all of it. The Milky Way and Andromeda are still bound together. They are moving toward one another and will eventually merge. Our local galactic neighborhood is not being torn apart by cosmic expansion. Gravity has won here. But on the largest scales, expansion wins, and over time, it wins more completely. Distant galaxy groups that are not bound to us will recede farther away. Their light will stretch to longer wavelengths. Their images will become dimmer. The galaxies will fade from view, not because they stop existing, but because the expanding universe carries their light beyond practical detection. In the far future, the sky will not show the same richness we see today. This future is one of the loneliest possibilities in cosmology. Billions and billions of years from now, the Milky Way and Andromeda will have merged into one enormous galaxy. The smaller galaxies of the local group may be absorbed or stretched into streams. The night sky inside that future galaxy may be filled with stars from both ancient spirals rearranged into a new shape. But beyond that local island, the wider universe will be fading. The Virgo cluster, distant superclusters, and countless galaxies in the cosmic web will move beyond easy observation. Their light will become weaker, more redshifted, more difficult to detect. Eventually, for future astronomers, the evidence of the larger universe may become almost invisible. They may look outward and see darkness. They may see their own galaxy, nearby stars, perhaps remnants of local companions, but the great cosmic web could be hidden from them. The universe will not be smaller. It will only appear smaller from their isolated position. This is a strange and almost tragic thought. The truth of the universe depends partly on when you live. We often imagine science as a steady process of discovering more and more, until the full truth becomes clearer. But the universe does not promise that evidence remains available forever. Some clues exist only during certain eras. We live during a window when the universe is old enough for planets, chemistry, life, and observers, but young enough that distant galaxies are still visible. We can see the cosmic web. We can detect the glow of the early universe. We can measure the expansion of space through galaxy redshifts. We can compare nearby galaxies with ancient ones and reconstruct cosmic history. A future civilization may not have that same view. It may be more advanced than us, more intelligent, more patient, and still be born too late to easily discover what we can see now. It may live in a galaxy surrounded by darkness and assume that the local island is nearly all that exists. This means our era is not central in space, but it is special in time. We are not at the center of the universe, but we are living during a moment when the universe can still reveal its vastness. The distance between galaxies is terrible, but the light from them still reaches us. The voids are enormous, but they have not yet hidden everything. The cosmic web is far away, but its image still arrives. We are receiving the universe before it grows too quiet. That makes every deep space image more precious. A photograph of distant galaxies is not just beautiful. It is a record taken during an era when those galaxies can still be observed. It is evidence gathered before expansion erases the view for future observers. It is a cosmic document. Every faint spiral, every red smudge, every distorted arc of gravitational lensing, every cluster of galaxies glowing in deep space, all of them are part of a temporary window of visibility. And the more we understand this, the more we realize that intergalactic distance is not only a physical measurement, it is a story about information. What can be known? What can be reached? What can answer back? What will remain visible? What will disappear beyond the horizon? The universe is not only made of matter and energy, it is also shaped by what can communicate with what. A region of space that can send light to us is part of our observable past. A region that can receive light from us is part of our possible future influence. These are not always the same. Between those two ideas lies a deep loneliness, because much of the universe may be visible only one way. It can speak to us through ancient light, but we may never speak back. This changes the meaning of galaxies in the sky. They are not all neighbors. Some are messages. Some are echoes. Some are evidence of places whose presence can never be shared with ours. And even for galaxies close enough to remain theoretically reachable, the time required is almost beyond meaning. Consider again Andromeda. It is bound to us by gravity. It is approaching the Milky Way. It is one of the few large galaxies that belongs to our long-term local future. It is not being carried away from us by expansion, and yet reaching it deliberately would still require a journey of millions of years even for light, and far longer for any realistic spacecraft. The closest major galaxy is not truly close. It is only close compared with the impossible distances beyond it. That is the cruel scale of the universe. Near means millions of light years. Far means beyond future contact. And most of reality lies somewhere in between, visible enough to inspire us, distant enough to remain forever separate. If a civilization wanted to survive the far future, it might focus on its local galaxy, rather than chase the unreachable universe. The Milky Way alone contains hundreds of billions of stars. Red dwarfs can shine for trillions of years. White dwarfs may cool slowly across immense time. Planets, moons, asteroids, and artificial habitats could provide countless places for life or intelligence to continue. A civilization that spreads through one galaxy could have more worlds than it could ever fully know. Perhaps that is why the universe is structured this way. Not intentionally, but physically. Galaxies may be the natural islands of civilization, large enough to offer unimaginable possibility, small enough, perhaps, to remain partly connected, separated enough that other islands become almost mythic. Inside a galaxy, signals can cross from star to star over years, decades, centuries, or millennia. Still difficult, but not always meaningless. Across a galaxy, the delays are severe, but a network could exist in some form if a civilization became patient enough. Between galaxies, the delays become geological. Communication turns into monument, exploration turns into inheritance, travel turns into transformation. And beyond the local group, expansion turns ambition into impossibility. This suggests that the universe may be full of isolated stories. Each galaxy could contain countless worlds, perhaps civilizations, perhaps life forms that rise, wonder, build, explore, and look outward. They may see other galaxies in the sky. They may know they are not alone in the cosmic sense, but they may never touch those other histories. A civilization in the Milky Way and a civilization in a galaxy hundreds of millions of light years away could both exist, both ask the same questions, both build telescopes, both search for signals, and still never share a living present. Their light may cross. Their knowledge of each other may not. The timing may be wrong by millions of years. The signal may be too weak. The expansion may place them beyond contact. One may vanish before the other even receives evidence that it existed. This is not the dramatic loneliness of being alone in the universe. It is a subtler loneliness. The loneliness of possible abundance without connection. The universe could be filled with islands of life and still remain quiet between them. Not because life is absent, because distance protects every story from every other story. This possibility changes the way we think about silence. When we ask why we do not hear from distant civilizations, we often imagine that maybe no one is there, or maybe they are hiding, or maybe intelligence destroys itself. Those may be possibilities, but distance offers another answer. The universe may be too large for voices to overlap. Civilizations may miss one another in time. Signals may arrive after the receivers are gone. Messages may be stretched, weakened, or lost. The gaps between galaxies make communication so slow that silence may not mean emptiness. It may mean delay beyond recognition. At intergalactic scales, even a greeting becomes ancient history. A civilization could send a signal across space with hope, and by the time it arrives, hope itself may belong to a vanished culture. This is why the distance between galaxies feels almost philosophical. It forces us to separate existence from contact. Something can exist and remain unreachable. Something can shine and remain unknowable in its present state. Something can be real and still never enter our story except as light. This is true not only for alien civilizations, but for planets, stars, and entire galaxies. We know they exist because their light arrives, but their internal reality remains mostly hidden. A galaxy may contain billions of planets, but from across intergalactic space, those planets vanish into blended light. Their oceans, if they exist, cannot be seen. Their atmospheres cannot be separated easily. Their weather, continents, chemistry, and possible life disappear inside the glow of hundreds of billions of stars. Distance erases individuality. A world becomes a pixel. A star becomes part of a haze. A civilization becomes invisible. An entire history becomes a slight change in a spectrum, if it is detectable at all. This is one of the deepest losses created by distance. The farther we look, the more we must exchange detail for scale. Nearby, a planet is a place. Farther away, it is a point. Farther still, it is hidden beside its star. Across galaxies, the star itself disappears into the galaxy. From another galaxy, Earth is not a world. It is not a blue sphere. It is not a planet with clouds, oceans, cities, forests, languages, music, and memories. It is nothing visible. It is buried inside the light of the sun. And the sun is buried inside the Milky Way. From far enough away, all of human history becomes part of one faint spiral. That does not make humanity meaningless. It makes our visibility limited. Meaning is local. The universe does not need to see us for us to matter. A song is still real if it cannot be heard across a galaxy. A life is still real if no telescope can detect it. A world is still real if it disappears into distance. But astronomy reminds us that scale and importance are not the same thing. The universe is vast beyond our reach, yet every local story remains complete to those living it. Perhaps this is how we should understand galaxies. Each one is a container of local meaning, a great island where stars and worlds form their own histories. From far away, it becomes a silent object. From inside, it may be full of storms, births, deaths, oceans, skies, and intelligence. The distance between galaxies hides this richness, and because it hides it, we must use imagination carefully. We cannot assume that a distant galaxy is empty just because we cannot hear it. We cannot assume that its worlds are simple just because we cannot resolve them. We cannot assume that silence means absence. The universe may be rich in ways that distance prevents us from proving. This makes every galaxy image feel like a closed book seen from across an ocean. We can see the cover, we can estimate its age, we can measure its brightness, we can infer parts of its structure, but the pages are hidden. Inside may be billions of stories, or none. We do not know. The distance keeps the book shut, and yet the fact that we can see the book at all is extraordinary. A photon from another galaxy has completed the crossing that no spacecraft of ours can make. It has traveled through intergalactic space, through the thin gas between galaxies, through regions shaped by dark matter, through expanding space, through time itself. It has survived long enough to reach a telescope near one small planet. When that photon is detected, it becomes data. When data becomes understanding, the distance changes form. It remains physically huge, but intellectually, part of it is crossed. This is the quiet miracle of astronomy. We do not need to move our bodies to learn the universe. The universe sends pieces of itself to us. Light is the messenger. Gravity is the sculptor. Radiation is the fossil. Spectra are the language. Telescopes are the ears and eyes we build to receive what distance allows to pass. Every galaxy we study is a conversation with ancient light, not a conversation with the galaxy as it is now, but with the galaxy as it was when the light began its journey. This means astronomy is always a study of time. The Milky Way around us is relatively present. Nearby stars are seen years or decades in the past. Distant nebulae may be seen thousands of years ago. Nearby galaxies are seen millions of years ago. Far galaxies are seen billions of years ago. The universe becomes older as we look deeper. Distance and time are tied together so completely that looking outward is also looking backward. This is not just poetic, it is physical. Light takes time to travel. The farther away the source, the older the light. When expansion is included, even the wavelength of light becomes a record of the universe's growth. A distant galaxy does not simply show its own past. It shows the history of space expanding between us. Its light stretches, its color shifts, its brightness fades. Its image may be distorted by intervening gravity. Every photon carries the imprint of its journey. The distance between galaxies is therefore not empty. It is filled with history, not human history, cosmic history. The expansion of space, the growth of structure, the movement of matter, the presence of dark matter, the influence of dark energy, the evolution of galaxies across billions of years. When we study the space between galaxies, we are not studying nothing. We are studying the largest processes in the universe. The emptiness has structure. The voids have history. The darkness has information. This is why cosmic voids are so important. They appear as absence, but they reveal how matter gathered elsewhere. They show where galaxies did not form in large numbers. They show how gravity pulled material into filaments and clusters. They show how the universe became uneven over time. A void is not just a dark gap. It is part of the cosmic design. If galaxies are the bright islands, voids are the oceans that define their separation. Without the voids, the cosmic web would not have its shape. Without emptiness, structure would lose meaning. But for travel, voids are terrifying. A large void may contain so few galaxies that a traveler inside it would feel almost outside the inhabited architecture of the cosmos. The nearest significant galaxy could be millions of light years away. A ship could move for ages without approaching anything that feels like a destination. The view might be beautiful at first, a dark sky with distant galaxies around the edges. But after thousands of years, beauty may become stillness. After millions, stillness may become identity. The travelers, if biological, would adapt to a life where the outside universe is mostly unreachable. They would become a society of interior spaces, artificial farms, artificial light, artificial cycles, artificial horizons. Their true landscape would be memory and machinery. This is why the distance between galaxies may favor machines over bodies. Machines can sleep, they can operate slowly. They can survive without psychology if designed well enough. They can travel without needing meaning in the human sense. But machines face time in another way. They decay. They require energy. They need error correction. They need protection. They must preserve instructions. A million-year mission is not only a propulsion challenge, it is an information challenge. How do you store knowledge for millions of years? How do you prevent memory from corrupting? How do you ensure that a machine still understands its purpose after cosmic rays, repairs, replacements, and adaptation? How do you send instructions to a probe when any command arrives too late to matter? The probe must become autonomous. But autonomy changes the nature of the mission. If the machine can decide for itself across millions of years, it becomes something more than a tool. It becomes a kind of descendant. Any successful intergalactic traveler may have to become independent from its origin. A generation ship becomes a civilization. A probe becomes an artificial explorer. A message becomes an artifact. Nothing remains a simple extension of the sender across galaxies. Distance cuts the cord. This may be the most important thing to understand. The distance between galaxies does not merely slow connection. It transforms connection into something else. A conversation becomes archaeology. A mission becomes inheritance. A destination becomes myth. A probe becomes a descendant. A civilization becomes an island. and an image becomes a memory. At cosmic scale, everything changes category. That is why the universe feels worse the more carefully we think about it. The first shock is size. The second is time. The third is expansion. The fourth is isolation. The fifth is transformation. To cross intergalactic space, a traveler cannot simply go somewhere. It must become something capable of surviving the journey. And by becoming that, it may no longer belong to the world that launched it. Perhaps this is why the galaxies are so quiet to us. Not because nothing is there, but because anything capable of crossing between them may be so transformed that we would not recognize it. If ancient machine explorers exist in intergalactic space, they may not communicate in ways we expect. If civilizations have launched self-replicating probes, those probes may follow goals older than stars we know. If messages cross the void, they may arrive in forms too weak, too brief, or too strange for our instruments. Or perhaps no one crosses at all. Perhaps most civilizations look outward, understand the numbers, and choose to remain within their galaxies. This would not be failure. A galaxy is already almost infinite from the perspective of life. The Milky Way contains more stars than any civilization could easily visit. It contains worlds we have not imagined, environments beyond our experience, ancient systems, newborn stars, planetary ruins, frozen wanderers, black holes, and perhaps countless opportunities for intelligence to survive. Why cross to another galaxy when your own remains mostly unknown? For most civilizations, the answer may be, they do not. They explore locally. They spread slowly. They study distant galaxies with telescopes. They learn that the wider universe exists, but they do not try to physically possess it. If this is common, then the universe may be filled with civilizations that are advanced within their own galaxies, but invisible across intergalactic distance. Not silent because they lack curiosity. Silent because the scale makes broadcasting across galaxies inefficient. Silent because their attention is local. Silent because no answer could return soon enough to matter. A civilization may decide that the universe beyond its galaxy is best understood through light, not travel. That may be wisdom, not limitation. Still, the human mind is drawn to the farthest shore. We want to know what lies beyond the Milky Way. We want to imagine crossing the darkness. We want to believe that no distance is final. This desire is not foolish. It is part of why astronomy exists. But the universe answers with humility. It says, you may look farther than you can go. You may understand more than you can reach. You may receive messages from regions you can never touch. And you may still find meaning in that. This is perhaps the most mature form of exploration, not the conquest of every place, not the arrival at every destination, but the willingness to know what cannot be owned, to see a galaxy and accept that it is real, beautiful, distant, and perhaps forever beyond contact, to understand that the universe is larger than our future. There is a strange peace in that. At first, it feels frightening to realize how separated galaxies are. The distances feel cold. The delays feel cruel. The expansion feels like a closing door. But after the fear comes a different feeling. Wonder, because even across all this separation, the universe is not completely silent. Light crosses the darkness. Gravity shapes motion. Ancient radiation fills space. Galaxies reveal themselves through photons older than continents, older than species, older than Earth itself in some cases. The universe may be impossible to cross physically, but it is not impossible to understand. Not completely. The fact that we can sit on a small planet and measure the distance to Andromeda is astonishing. The fact that we can detect galaxies billions of light years away is astonishing. The fact that we can map cosmic filaments and voids, infer dark matter, measure expansion, and look back toward the early universe is astonishing. We are not powerful compared with the universe, but we are aware, and awareness is not nothing. The universe has produced, at least here, matter capable of looking back at the distances that shaped it. Atoms formed in stars became planets. Planets produced chemistry. Chemistry produced life. Life produced minds. Minds built telescopes. Telescopes caught ancient light. Ancient light revealed galaxies beyond reach. In this way, the universe becomes conscious of its own separation. Through us, a tiny part of the Milky Way knows Andromeda is there. Through us, one island of stars recognizes the ocean around it. This does not make the ocean smaller, but it makes the island less blind. That may be enough. As this journey reaches its end, imagine the Milky Way from far outside. A luminous spiral turning quietly in the darkness. Somewhere inside one of its arms, the sun is hidden among billions of stars. Around that sun, Earth moves silently. On Earth, creatures look up and ask how far the next galaxy is. From that distant view, the question seems almost impossible. Earth cannot be seen. Humanity cannot be seen. Our cities, languages, memories, hopes, and fears are invisible. And yet, those invisible beings have measured the distance. They know that Andromeda lies millions of light years away. They know that clusters stretch across greater depths. They know that voids occupy enormous volumes. They know that expansion is carrying much of the universe beyond future reach. They know that the galaxies in the sky are not close. They are ancient lights across oceans of time. Now imagine zooming out farther. The Milky Way and Andromeda become small members of the local group. The local group becomes one tiny part of a larger cosmic region. Clusters appear. Filaments stretch. Voids open like dark chambers between glowing walls. The cosmic web emerges. Beautiful, immense, almost alive in its structure. But every thread is larger than human history. Every gap is a distance no ordinary journey can cross. Every bright knot contains galaxies separated internally by their own vast spaces. And beyond all of it, the universe continues. Some parts visible, some parts unreachable, some parts beyond the horizon entirely. There may be more galaxies than we can ever observe, more voids, more structures, more histories. The observable universe is not guaranteed to be the whole. It is simply the part from which light has reached us. Beyond that limit, there may be more reality forever hidden. This means even our largest maps are incomplete. The edge of what we see is not necessarily the edge of what exists. It is the edge of our information. A boundary made of time and expansion. That may be the final humbling truth. We are not only unable to cross the universe, we cannot even see all of it. The galaxies we observe are only the visible portion of a larger unknown. And within that visible portion, many galaxies are already beyond reach. And within the reachable portion, the journeys are so long that only transformed descendants, machines, or messages could attempt them. The universe is layered with limits. Limits of travel, limits of communication, limits of observation, limits of survival, limits of imagination. But a limit is not always an ending. Sometimes it is the shape of understanding. By knowing where our reach ends, we understand more clearly where we are. We live inside the Milky Way, a galaxy enormous enough to hold hundreds of billions of stars, a galaxy that itself is only one island among countless others. A galaxy moving through a universe that is expanding, evolving, and slowly separating its distant regions. We are not trapped in a small place. We are born inside something vast, and beyond it lies something vaster still. The distance between galaxies is worse than we think because our minds shrink it automatically. A line on a screen between the Milky Way and Andromeda looks simple. A number like 2.5 million light-years can be spoken in a breath. A deep-field image makes thousands of galaxies appear close together. But behind those images are millions and billions of years. Behind those numbers are civilizations that could rise and vanish before a signal returns. Behind those lines are voids large enough to swallow imagination. The universe is not close just because we can photograph it. It is not reachable just because it is visible. It is not waiting just because it shines. And still, it shines. That is the part that remains beautiful. Across distances that defeat travel, light arrives. Across silence that defeats conversation, evidence arrives. Across time that defeats memory, history arrives. A galaxy may be unreachable, but it is not unknowable. A void may be empty, but it is not meaningless. A horizon may limit us, but it also defines the region from which the universe has spoken. Tonight, the light of Andromeda continues falling on Earth. It began its journey before humanity existed. It crossed the darkness without knowing there would be eyes waiting. It traveled through intergalactic space, entered the Milky Way, passed through the solar system, and reached this small world. The same is true for countless other galaxies. Their light arrives quietly. No sound, no announcement, no promise of contact, just photons, older than memory, carrying proof that beyond our galaxy there are other islands in the dark. And maybe this is the most honest way to understand our place. We are not masters of the cosmic sea. We are listeners on one shore. We see distant lights. We measure their motion. We learn their history. We dream of crossing, but we also learn why crossing may never happen. That knowledge is not defeat. It is perspective. The distance between galaxies tells us that the universe is bigger than ambition, bigger than technology, bigger than any one civilization's future. But it also tells us that knowledge can travel where bodies cannot. A telescope can become a bridge of light. A question can cross the boundary of the familiar. A mind can hold a map of places no hand will ever touch. This is what makes astronomy so powerful. It does not bring galaxies closer. It makes our understanding larger. And perhaps that is enough to change us. When you see a galaxy in the night sky or in a deep space image, do not think of it as just a distant object. Think of it as a whole realm, a place with billions of stars, possibly billions of planets, a history unfolding beyond our present, a light that survived an ocean of time to reach us. Think of the darkness around it, not as empty background, but as the true scale of the universe. Think of the expansion carrying distant regions away. Think of the future, when many of those lights will fade from view. Think of the civilizations, if they exist, that may look from their own galaxies and wonder whether the universe is also too large for them. Maybe every intelligent species eventually reaches this same realization. Maybe every sky on every world capable of wonder teaches the same lesson. The universe is visible beyond reach, beautiful beyond possession, connected by light, divided by time, and filled with distances that turn even galaxies into lonely islands. The distance between galaxies is worse than we imagine. But perhaps the fact that we can imagine it at all is the miracle. A small mind on a small planet can think about millions of light years. A civilization only a few thousand years into science can study galaxies billions of years old. A species that has barely stepped beyond its moon can understand that the universe contains horizons no spacecraft may ever cross. We are tiny, but we are not blind. And in a universe where so much is separated, seeing clearly is a kind of connection. The galaxies remain far away. Andromeda still waits millions of light years across the dark. The cosmic web stretches beyond ordinary thought. The voids continue opening between the filaments. Expansion continues carrying distant regions towards silence. But here, for now, the light still reaches us. Here, for now, the universe still tells its story. Here, for now, one world can look into the distance and understand that the darkness is not empty. It is filled with ancient journeys. It is filled with unreachable shores. It is filled with galaxies whose light has crossed time just to become a faint glow in our sky. And that glow is enough to remind us of the truth. We live inside one galaxy. Beyond it lie others. Beyond them, more, and between them all, the greatest distance humanity has ever tried to understand. A distance made of space. A distance made of time. A distance made of silence. A distance so vast that even light grows old before it arrives. And yet, across that silence, the universe still speaks. Quietly, patiently, from galaxy to galaxy, from the ancient past to the present moment, from the far shore of darkness to us. There is another way to understand the distance between galaxies. Do not begin with numbers. Begin with memory. Think of the oldest stories human beings still remember. Ancient cities buried beneath sand. Stone monuments built by hands whose names are gone. Languages that survive only in fragments. Kingdoms that once believed they would last forever, now reduced to ruins, symbols, and dust. Human memory is short compared with Earth. Earth memory is short compared with galaxies. And galaxy distance is so large that even memory becomes too fragile to cross it. A message sent to another galaxy is not just traveling through space. It is traveling beyond the natural lifetime of cultures, beyond the stability of languages, beyond the survival of nations, beyond the structures by which a civilization understands itself. This is why intergalactic distance is not only an astronomical problem, it is a problem of continuity. How does meaning survive when the journey is longer than everything that gave the journey meaning? If humanity sent a spacecraft toward another galaxy, the launch would be a historic moment. People would gather around screens. Scientists would speak about the mission. The world would know that something built by human hands had begun the longest journey ever attempted. For a while, the mission would be famous. Then, it would become part of science history. Then, after centuries, it might become a symbol. After thousands of years, perhaps a legend. After hundreds of thousands of years, if humanity still existed, the mission might be remembered only by archives, if those archives survived. After millions of years, the spacecraft would still be traveling, still surrounded by darkness, still far from its destination. And the civilization that launched it might be unrecognizable. This is the true pressure of intergalactic distance. It forces everything to outlast itself. Machines must outlast their makers. Messages must outlast their languages. Purposes must outlast the societies that created them. Even if the spacecraft survives, the meaning of the mission may not. A civilization could begin a journey with one intention and become something entirely different before the journey is complete. A generation ship makes this even more complicated. Imagine a vessel large enough to support human life for immense periods of time. It carries habitats, farms, water systems, energy systems, medical knowledge, education, culture, and governance. It leaves the Milky Way and begins moving toward Andromeda or another galactic destination. The first generation knows Earth. They remember oceans, skies, weather, cities, gravity, and natural landscapes. The second generation knows Earth through stories. The 10th generation knows Earth through education. The 100th generation may know Earth as sacred history. The 1000th may know it as an origin myth. After enough time, Earth becomes less like a place and more like an idea. The ship becomes the real world. Its artificial lights become the sky. Its rotation or gravity systems become normal. Its walls become geography. Its engines become history. Its destination becomes a distant promise that no living person has ever approached. And outside the ship, the universe changes too slowly to provide emotional proof of movement. The Milky Way behind them may shrink across generations, but not across days. Andromeda ahead may brighten across eras, but not across individual lifetimes. The people inside may ask a question their ancestors did not expect. Why are we still going? That question may be more dangerous than any asteroid, any radiation storm, or any mechanical failure. Because a mission that lasts millions of years cannot rely only on engineering. It must preserve belief. It must preserve trust. It must preserve a shared reason to continue. But no culture remains unchanged forever. New beliefs appear. Old ones fade. Power structures shift. Conflicts emerge. Knowledge can be preserved, but interpretation changes. A scientific mission can become a religious pilgrimage. A survival project can become a prison story. A destination can become a threat. The ship may divide between those who want to continue and those who want to stop, between those who honor the ancient mission and those who believe their ancestors had no right to choose their future. In this way, the distance between galaxies becomes political. It becomes cultural. It becomes emotional. It asks whether a society can remain stable when the reward belongs to descendants so distant they may no longer feel connected to the people who began the journey. Perhaps no biological civilization could remain unchanged for that long. Perhaps any successful intergalactic traveler would have to accept transformation as part of the mission. The goal would not be to send humanity exactly as it is. The goal would be to send something that can become what the journey requires. That thought is unsettling, because it means that crossing galaxies may not preserve a civilization. It may create a new one. A civilization born in transit. A people of the void. Not Earth people traveling to another galaxy, but ship people whose entire identity comes from the space between galaxies. If they arrive, they might look at a natural planet with fear rather than longing. Open skies might feel exposed. Weather might feel violent. A horizon might feel strange. The silence of a forest might be more frightening than the hum of machines. The destination that inspired the mission may not feel like home. This is one of the strangest consequences of distance. A journey can last so long that arrival becomes alien. Andromeda might not be the end of the journey. It might be the first time the travelers realize they no longer belong to planets at all. Robotic missions seem easier, but only at first. A machine does not need culture. It does not need comfort. It does not become lonely in the human sense. It can sleep for long intervals, conserve power, and wake when needed. But over millions of years, even machines face identity. If a probe must repair itself again and again, replacing damaged parts with stored material or resources it finds, how much of the original probe remains? If it rewrites software to adapt to unexpected conditions, is it still following its original mission or creating a new one? If it develops advanced decision-making because no signal from Earth can arrive in useful time, is it still a tool, or has it become an independent explorer? The distance between galaxies cuts the connection between creator and creation. A probe sent into intergalactic space cannot wait for permission. It cannot ask for help. It cannot depend on instructions. It must survive as if alone in the universe, and if it survives long enough, it may become the most distant descendant of its makers. Not alive in the biological sense, perhaps, but carrying intention across a scale biology could not endure. This may be the most realistic form of intergalactic travel, not humans in ships, but autonomous descendants of intelligence. Machines built to preserve knowledge, adapt, repair, and continue. But even then, the mission is almost impossible. The probe must protect itself from time. Time is the invisible environment of intergalactic space. Radiation slowly damages electronics. Dust impacts accumulate. Power systems decay. Materials weaken. Tiny errors become serious when there is no repair crew from home. Memory must be protected against corruption for spans longer than any human archive has survived. The probe must know how to forget damaged data without losing truth. It must preserve maps, instructions, scientific goals, and perhaps information about the civilization that built it. And if it finally reaches another galaxy, the first thing it sees may not be a world. It may only enter the outer halo of another massive structure. Sparse stars, dark matter, ancient clusters, thin gas. The actual search would begin there. After millions of years crossing the darkness, the probe would still need to find something worth studying. A planet, a star system, a region of interest, another civilization, if one exists. Reaching a galaxy is not like reaching a door. It is like reaching another ocean after crossing the first. The galaxy contains billions of possible directions, and the probe alone must choose. This reveals a hidden truth about galactic destinations. A galaxy is not a target. It is a field of targets. When we say travel to Andromeda, we make the idea sound simple. But Andromeda is enormous. It contains a central region, spiral arms, star clusters, dust lanes, old stellar populations, young stars, gas clouds, satellite galaxies, and a vast halo. Arriving anywhere near Andromeda does not mean arriving somewhere useful. A spacecraft could enter the galaxy and still spend thousands or millions of years moving between star systems. It would need to decide whether to study the outer halo, move toward the disk, search for planets, investigate black holes, follow signs of chemistry, or simply transmit a map. But any transmission back to the Milky Way would take millions of years. There would be no celebration on Earth in any immediate sense. No live broadcast, no mission control applause, no real-time discovery shared with the people who launched it. The discovery would belong to the probe first, and maybe only to the probe. This is why intergalactic missions, if they ever happen, may not be missions in the way we understand them now. They may be acts of release. Humanity, or any civilization, sends something outward knowing it may never know the result. Not exploration as possession, exploration as donation to the future. A gift sent into time. A message to unknown descendants. A seed of knowledge thrown across darkness. This is a very different kind of ambition. It is quieter, more patient, Less about conquest, more about trust. Trust that something may survive. Trust that knowledge may matter even if the sender never receives the reward. Trust that a light carried from one galaxy to another has value even without applause. Perhaps this is the only attitude large enough for the universe, because the cosmos does not move at human speed. It does not arrange its distances around our plans. It does not guarantee that every question receives an answer in the lifetime of the questioner. The universe teaches patience, and galaxies teach the most extreme patience of all. But there is another side to this. Maybe intergalactic travel is unnecessary, because the Milky Way itself is already more than enough. This is easy to forget. When we look beyond our galaxy, we are drawn to what is farther. Andromeda feels mysterious because it is outside. The cosmic web feels grand because it is larger. Distant galaxies feel like the next frontier, but our own galaxy remains almost completely unknown to us. We have explored only a handful of worlds directly. We have sent machines to planets, moons, asteroids, and comets in our own solar system. We have not visited another star. We have not mapped most planetary systems in detail. We do not know how many habitable worlds exist in the Milky Way. We do not know how many hidden oceans orbit distant suns. We do not know how many civilizations may have risen, failed, survived, or remained silent within our own galaxy. The Milky Way contains enough mystery for millions of years of exploration. If a civilization spreads through its own galaxy, it may never need another. Every star could be a project, every planet a study, every moon a possible habitat or archive, every black hole a laboratory, every nebula a record of creation, every ancient star a clue about the early galaxy. The desire to cross to another galaxy may come not from necessity, but from imagination, from the part of intelligence that always asks what lies beyond the next boundary. That desire is powerful. It may push civilizations outward, but the universe may answer with a different wisdom. Before crossing the abyss, understand the island. Before chasing Andromeda, understand the Milky Way. Before dreaming of the cosmic web, learn the worlds around your own star. Maybe galaxies are separated so deeply that they become natural chapters of cosmic life. Each galaxy may be large enough to hold countless stories, separate enough to develop its own histories, visible enough to remind its inhabitants that others exist, distant enough to prevent easy contact. If that is true, then the universe may be filled with islands of meaning, not isolated because nothing connects them, but isolated because connection is slow. Light connects them, gravity connects them, history connects them, but ordinary life does not. A civilization in another galaxy may look at the Milky Way and see only an ancient spiral. They may wonder if anything lives inside it. They may build myths around its shape. They may measure its light, mass, and movement. But they would not see Earth. They would not hear our current voices. They would not know our present. To them, we would be hidden inside galactic light. And to us, they would be hidden inside theirs. This is what distance does to life. It makes it invisible without making it impossible. A living world across another galaxy could be real and completely unknown. A civilization could be brilliant and still undetectable. A history could unfold for millions of years and leave no sign strong enough to cross the abyss. The universe may contain many minds looking outward, all separated by the same darkness, each believing the silence is evidence, each not knowing that others are simply too far away. This possibility changes the feeling of the night sky. The darkness between galaxies is not necessarily dead. It may be a curtain. Behind it, galaxies contain stars. Around those stars, planets may exist. On some planets, perhaps oceans move. Chemistry changes. Atmospheres glow. Storms rise. Life begins. Intelligence appears. Questions are asked. Telescopes are built. And still, across millions of light years, almost none of it can be shared. The great tragedy of the universe may not be emptiness. It may be separation. But separation is not the same as meaninglessness. A story does not need to be known everywhere to matter where it happens. Earth matters here. A distant world matters there. A civilization hidden in Andromeda would matter to itself even if the Milky Way never knew it existed. Maybe this is the emotional lesson of galactic distance. Importance is not measured by cosmic visibility. The universe can be enormous, and local life can still be profound. A person standing under the stars may be invisible from Andromeda, but the experience is still real. A civilization may never be heard beyond its galaxy, but its knowledge, art, love, struggle, and curiosity still belong to the universe. Scale does not erase value. It only humbles perspective. And perspective is what astronomy gives us. We cannot physically hold a galaxy. We cannot cross most of the distances we measure. We cannot see every world hidden inside a spiral of light, but we can understand that they are there, or may be there. We can understand that the darkness is vast. We can understand that light carries memory. We can understand that the universe is older, larger, and more separated than our ancestors could have imagined. And that understanding changes the way we see home. The Milky Way is no longer just a band of light in the sky. It becomes our island. Earth is no longer just the ground beneath us. It becomes one small world inside a vast galactic structure. The sun is no longer just the source of day. It becomes one star among hundreds of billions, moving through a galaxy that itself moves through the cosmic web. And the galaxies beyond are no longer just distant objects. They become reminders of the limits of reach, reminders that existence is larger than contact, reminders that the universe does not need to be accessible to be real. This is where fear becomes wonder. At first, the distance between galaxies feels cold, too large, too silent, too final. But then we realize that across this silence, light still arrives. The universe still shares itself. Not quickly, not completely, not in a way that allows easy conversation, but enough for understanding, enough for awe, enough for one small species to know that the Milky Way is not alone. That may be one of the greatest achievements of consciousness, to look at a faint glow in the sky and realize it is another galaxy, to measure the time its light traveled, to understand that the photons entering a telescope began their journey before our species existed, to know that the universe is not a small room, but a vast and evolving ocean of islands, and to accept that most of those islands may remain untouched. There is sadness in that, but also peace, because not every beautiful thing must be reached. Some things are meant to be seen from afar. Some truths are meant to expand the mind rather than the map. Some distances are not invitations to conquer, but lessons in humility. The galaxies beyond the Milky Way may never know us. We may never know them in detail, but their light has already entered our story. It has shaped our science. It has changed our understanding. It has taught us that the universe is filled with other great structures, other histories, other possibilities, and perhaps that is a kind of connection. Not the connection of travel, not the connection of speech, but the connection of awareness. The universe becomes known to itself through observers who receive its light. A galaxy shines, another galaxy observes. Across the darkness, information passes, and for a moment the distance is not defeated, but honored. This may be the final way to think about intergalactic space, not only as an obstacle, not only as a void, but as the medium through which ancient light travels. The darkness between galaxies is the reason the journey is impossible, but it is also the reason the message is ancient. It turns photons into time capsules. It turns galaxies into memories. It turns observation into time travel. Without distance, the universe would not reveal its past in the same way. Without delay, we would not look outward and see earlier cosmic eras. Without the vastness between galaxies, astronomy would lose one of its deepest powers. So the same distance that separates us also teaches us. It prevents contact, but preserves history. It blocks travel, but carries light. It makes the universe lonely, but also readable. And maybe that is enough for now. Maybe humanity's first role is not to cross the galaxies, but to understand why crossing them is so hard. To learn the shape of the cosmic web, to measure the expansion, to map the voids, to study Andromeda's ancient light, to recognize the limits that define our place, and to grow wiser from those limits. Because a civilization that understands its limits is not weaker, it is more awake. It knows the difference between dream and physics, between desire and distance, between visibility and reach, between loneliness and emptiness. The distance between galaxies is worse than we think because it touches everything. Travel, communication, memory, identity, civilization, the future, the meaning of exploration itself. It forces us to ask what kind of beings we must become if we ever try to cross the darkness. And it also teaches us that the universe can be worth studying, even when it cannot be possessed. Tonight, the galaxies remain where they are, or rather, where their ancient light tells us they were. Andromeda still glows softly across millions of light years. Distant clusters still send us photons from deep cosmic history. The voids still open between the filaments. Expansion still carries unbound regions farther away. The universe continues its quiet movement. And here, on one small planet inside one galaxy, we look outward. We may never reach most of what we see, but we can understand that it exists. We can receive its light. We can let its distance change us. And sometimes, that is the most powerful journey of all.